Hello everybody. In this video I will show you how to use quadratic proving method to resolve hash collision. Hash collision is a situation in which two or more different elements hash to the same memory location or same position in a table. So here I am taking four different hash values 25, 26, 34, 35 and created a one hash table starting from index 0 to 14. Now I am using the concept of division method to hash these values to that given table. So initially I will be dividing that 25 by 10. I will get remainder 5. So this 25 will be stored in fifth index of this table. Similarly 36 is divided by 10 and it will give me remainder 6. So 36 will be stored within the index 6 of this table. Similarly 24 divided by 10 I will get remainder 4. So 24 will be stored in index 4 of this table. Similarly 35 divided by 10 it will give me remainder 5. Now the index 5 of this table is already occupied by 25. So this situation in which two different element has to same position is called hash collision. And hash collision can be eliminated or resolved using different techniques like linear proving, quadratic proving. In this video I will show you how to write Java program for proving. So here what we do is for this 35 the hash value is equal to, why is this coming, hash value is 5. So I will increase that hash value. I will use a increase hash value by 1 plus equal to 1. So this value will become 6 and I will check in this table whether the 6th index position is available or not. Here 36 is already stored, so this space is not available. So again I will increase this hash value, this time by 2 into 2. That is, I will square the value. There will be a counter. That counter starts from 1 to 3. So here suppose I is the counter and I is 1. Here I is the counter, I will be 2. So 2 will be squared. So the hash value here will be 5 plus 4. That is 5 plus 4 is equal to 9. So in this table index number 9 will be checked and we find here the empty position. So 35 will be stored here. Okay, that is the basic idea behind linear proving collision resolution method. So now let's see how to program this collision resolution method, the linear quadratic proving. Okay, let's start coding. Class quadratic proving. Now let's define the main method. Public static void main. Now let's define and hash values list as a list. Okay. Okay, now these are the values which we have to map to a table. Now let's define a table of size 100. Okay, now to the hashing I will be defining one method here. So public static int, now get hash value. I will return, there will be a value passed to this method n modulus. I will be using 97 as a divisor. Okay, so this is a prime number. Now what I do is I will loop through this list, these values. Okay, it will be better to make name list. I will loop through this list. I list, where is my I? Now I will define one variable int hash value equal to get hash. Then in this, to this function I will be passing I. Okay, now I will check in the table if this index has index value given by hash value is empty or not. 0 means empty. If it is empty, then I will assign this value to that index position, hash value. So I. So here what I am doing is I am trying to loop through the list. So on that list will be accessed one by one. Initially the value of I will be 22, and this 22 will be hashed using this get hash value, and this hash value will get the remainder. In that case, very easy, that it will be 22, and in the table index 22 will be checked for emptiness. That is, if it is 0, then we'll assign this 22 to the index 22. If that position is not empty, then what we will do, what will happen? So we have to find another empty position. So we have to use the loop here for int. Okay, let's make j less than 100, j plus plus. Now what we'll do, we'll change the hash value something like this. Hash value plus is equal to j into j. That is the basic idea behind quadratic proving, squaring j. Okay, now again we have to check if this position in the table is empty or not. That new hash value, new position, if it is 0, then we can assign this value, the list value here, that is I. Okay, that is I, and we have to break the loop. Okay, in this way this for loop will try to find the empty position for the value within the list. Okay, in this way we can map the values given and list to the table. If collision occurs, that collision will be handled by this logic, this module. Okay, this part of the method will handle the collision. Now let's display the content of this table. For int I is equal to 0, I less than 100, I plus plus. Now we have to check if table I not is equal to 0, then we will be displaying the values. Plus table I. Okay, QA quadratic proving dot java. Let's hope that I have written the spelling correct. Quadratic. Let's, okay, it seems fine. Now let's execute this. Java CQ. Okay, there is a error. Hash value. Oh, I forgot to put that semicolon here. Where is in line number 10? Where is my line number 10? Okay. Okay, instead, okay, this should be semicolon. Now is there anything, what is this for? Okay, this loop is of this. Okay, okay, there is a mismatch of the opening and closing curly braces. So now why I'm writing this? Okay, let's go to the dash alias Java CQ. Okay, wow. Okay, I forgot to specify the square brackets here. Silly mistake I used to make. Okay, let's recompile this. Okay, fine. Now it is not giving me anything. It is not displaying. Oh, this is not one. This should be I. What? So many mistakes. Okay, let's recompile this. Okay, now you can see. Okay, the 2 is stored in index 2, 22 in 22, 332 in 41, and so on. So I think there is no collision. There, how many elements are there? There are 7 elements, and all of these 7 elements are assigned in the table or mapped in the table. Now let's make a collision. There is 22. Now let's store 22 in the list. Now initially this 22 will occupy position 22 within the table, And when this 22 arrives, it will be again getting the hash value of 22. But that position in the table is already occupied by this 22. So the collision will be detected. Now this logic will be in action to handle that collision. Now let's see where this second 22 will be stored. Now let's do CLS. Okay. Okay, you can see this 22 initially stored in index 22, but when this 22 came, then this logic checked for the empty space. So initially the value of j equal to 0, I should have used 1, would have been better. Okay, I used 0, no problem. So when it will become 1 into 1, this is 1, as value was 22, 22 plus 1, 23. So we can see this 22 being stored in the position or index 23. So in this way we can use this hash resolution or hash resolution method, the quadratic proving, to resolve. Okay, so that is a very simple logic. Thank you for watching.